Okay, today we're going to be comparing direct variations to inverse variations. And so a direct variation is when our equation is in the format y equals kx. We can see that the graphs form a straight line and that they pass through the origin. We also know that in our k, in order to find our constant of variation, we would do y divided by x. An inverse variation is where we're going to see this curved line, and we're going to see that they're in opposite quadrants. So the one in the first and the third quadrant, or the second and the fourth quadrant. And that's represented by the equation y equals k divided by x. And so in order to find our constant of variation here, we would be multiplying x times y. So when we're looking at data, we're going to be looking at that constant of variation. How do we find k? And that will tell us whether it's a direct variation or whether it's an inverse variation. So if we have a table of values and we want to decide whether we have a direct variation or an inverse variation, remember that a direct variation, we would have our k is equal to y divided by x. And if we had an inverse variation, our constant of variation would be equal to x times y. So when we're looking at our x and y values, we want to look for a constant k that's the same for all of these. So if I look at 1 and 5 and 2 and 10, and I want to see if it's direct, I would plug in my x and y and see if I get the same value. So for my first ordered pair, the constant of variation, if this was a direct variation, we don't know yet, 5 divided by 1. And then I'm going to check my second ordered pair, and I would have 10 divided by 2. And I can see that both of those are equal to 5. Now, if I look at the inverse variation and I were to multiply them, right, then I were to have 5 times 1 is 5, but I can see that it's not constant here. 2 times 10 is 20. So we can see that it's not inverse because we didn't get a constant k. So that would make this a direct variation. Now, if I do not have a table of values, but I have an equation, I want to solve my equation for y equals and everything else over here. That way I can compare it to my direct variation equation, y equals kx, or my inverse variation equation, y equals k divided by x. So my goal here is to get y by itself, so I'm going to divide by 4x. And so I have y equals negative 1 over x. So I can see that division. I can see that my constant of variation is negative 1. It fits into this format, so this is an inverse variation. Okay, so now I'm told that I have a direct variation, and I want to come up with the equation. So my equation is y equals kx for a direct variation. I'm going to plug in 12 for x and negative 6 for y to find my constant of variation. So I'm going to divide by 12, and I can see that k is negative 1/2. So that gives me the equation y equals negative 1/2 x. Now it wants me to do a graph. So I'm going to graph this. And again, direct variations go through the origin. And my slope, negative 1 over 2. So I go down 1 over 2, down 1 over 2. And here would be my line for my direct variation. Do the same thing, but this time I have an inverse variation. So now I'm looking at the equation y equals k over x. So I'm going to plug in 2 for x and 5 for y. I'm going to solve for k. So I'm going to multiply both sides by 2. So k equals 10. So we have y equals 10 over x. Now this is going to give me that curved situation. So in order to do my graph, I'm actually going to make a table of values. I'm going to give myself some space over here to do that. So I'm going to start with 1, 2, 3, and then I'll do -1, -2, and -3. Yeah, because I'm doing multiples of 10, maybe I'll do 5. I don't know, we'll see. And so we have 10 divided by 1 is 10. 10 divided by 2 is 5. 10 divided by 3 would be 3 1/3. 10 divided by 4 would be 2 1/2. 10 divided by 5 would be 2. So I'm going to graph these. And here we go. Let's see, I've got 1, 10. I've got 2, 5. I've got 3, 3 1/3. I've got 4, 2 1/2. 4, 2. I can already see that curve happening. I'm going to do another one. You can see it's going to approach 1. Because if I get out to 10, I would have 10 divided by 10 as 1. So here's my curve here. And then I would have a matching curve on the other side for my graph.